Okay. Do you have a slideshow, Ashwini? Okay.
That's right. If you could enable the screen share.
Okay. It should work momentarily.
Perfect.
Wonderful. You have the floor. If you need anything, just call for me. I'm going to mute myself.
Thank you so much, Nicole. Thank you very much. So hello, everyone. It's awesome to be over here again. This is my second year. I am going for this competition for the students. It was an amazing journey for me personally. I am an aerospace engineer, and I always wished to have something like this, something challenging. I had to wait all the way till I did my bachelor's, to get to do something cool about engineering, about designing. But I'm very glad and happy that you all are able to get this chance right away. So today I'm quickly going to turn and talk about what do we do? So you all have this task. I know that you have to not only just go to Mars. I mean, you're already there on Mars. Your astronauts are going to be there. And how are you going to supply everything that they need to survive there, right? So on Earth, you're so lucky. We have everything. We just so easy. It's easily reachable. On Mars, you have to think about how you're going to get the air, right, from the basic air, water, then food. So I thought about, let's talk about food. How do we get food? What have we been doing so far to get food in space? Okay, so yep, let's get started. Let's talk a little bit about that. So first of all, why do we need food? Obviously, we know that it's a source of energy for humans, so we definitely need that. And sometimes food is also like a motivation, right? I mean, like you are studying, you're stressed, and there is something to eat for you. You're like, oh wow, yeah, now I can concentrate more if I eat more, if I eat better. It gives you motivation, it gives you energy, it keeps you going. You need it, and you don't like to eat the same food every day. You'll definitely get bored. Now think about your astronauts. You're going to send them all the way there. They're going to be there for a long time, 6 months, 1 year, whatever your mission plan is. So how are they going to survive? You cannot just give them a freeze-dried food and tell them to eat that. At one point, they will start complaining. They'll start saying, I don't want to do this anymore. This is boring. You never know what might be the reason, but the reason might be food. So definitely food is important, and you need to have variety. Remember that. Okay, so what are the types of food that we can have in space? It can be a processed food, like packed one, okay, which is already cooked, packed ones. Or it can be a raw food, that's something that's available, and then you cook it and then you eat it, right? So let's see about the processed food or whatever the food that you're going to send. It's very important to keep this in mind, the rules, how it should be. We might say that, yeah, your task is not to travel all the way in the space. I mean, space is the where you think about keeping things compact, lightweight, and things. But even then, even though you're on Mars, you are limited in space, right? So therefore, you need to think and make sure that you keep the food compact. Okay, it should not. Okay, so you cannot take your bag of chips. It's not possible. It's going to consume a lot of space. It has to be lightweight. A bag of chips is lightweight, but that's not enough because it's not nutritional. So it has to be lightweight and nutritional. Usually we say that, I mean, there is a thinking that astronauts don't feel taste. That's not true. You may take a while to adjust yourself. Your taste buds might take a while, but you do feel, you do need tasty, nutritional, and good food. Yeah. Should not be powdery. It doesn't matter much on Mars, but still, let's try to avoid that, I would say. And it should be long lasting, of course. You are going to stay for whatever time you're going to be there. You need it for a longer period of time. And previously, the packages used to be something like that, in a tube like this or packed up in a vacuum pack. We are trying. There is a lot of research in which you can reduce the weight of the metal tubes. Okay, so I'll just quickly share with you a video of where I think astronauts. So this is a very common video that you can find anywhere in the YouTube, where the astronauts are showing how they eat their food. So before we get into different types of processed or packed food, I'll just show you how they eat it so that you know what are the systems are there and you can include those systems in your design. Okay, so here it comes.
Welcome back to Expedition 62 on the International Space Station. Tonight we thought we would show you a little bit about some meal prep, what we do for meals on board the space station.
Just give me a minute, I'll try to put it on full screen. There you go.
How do we prepare our food? So the answer is, we have a great variety of food up here.
Two different general types of food, thermostabilized food in these green packets that's very similar to military MREs or meals ready to eat. And then we also have freeze-dried food.
So all of the water content has been sucked out. This is just basic asparagus, so we need to add the water back in. We want to make sure all that water is mixing in, and then we usually put it here inside the food warmer.
And then we have refrigerated space here. They've been nice enough to allow us to use these just for food. All right,
Dinner
the dinner
time.
table.
Some Turkish fish stew. I have butternut squash.
All right, and I'm having, I have rice with butter, some lentil soup, and grilled chicken patty. A lot of the Russian food comes in cans. This was one of my favorites. This is spicy beef and rice.
Space makes eating a lot more fun. You can turn your spoon upside down, or even let it go, and nothing's gonna fall off. You can eat in any direction. You can eat upside down if I want to.
Okay, so that was some fun the astronauts were having in space. Definitely, no one would like to miss that. Okay, so moving further, now let's see what are the ways you can pack your food. Okay, so it could be a rehydratable food, like the one that you saw just now. The asparagus was just for, like all the water content was removed from it, and then you refill the water, and then you make it mushy, right? So that's rehydratable ones. Like over here, we have peas, or orange drink, or chocolate milk. So we could have that there. Or we can have, so the advantage of having a rehydratable food is you don't have water in it and it won't leak. Okay, you can add water only when you are using it. So there is no waste. It reduces the weight. Okay, and then you have thermostabilized food. So you all might have seen some things like in the canned foods, right? Like carrots or corns. If you observe them, they are, like you boil it for a very short period. So then you're removing all the bacteria from it. We know that boiling always removes unwanted things from it, unwanted things from the food. That's one way, thermostabilized food, they'll last longer, okay? Or irradiated food, in which you pass some radiations through the food. Now, this doesn't mean that you have to do this for the packed food alone. Maybe you have the food over there and you have a crop that grows together, a lot of produce at a time. How do you store them? So these are the methods that you can think about when you want to store your food, even on Mars. Okay, so irradiated food. So what happens? We know that the radiations are very tiny. They can pass through anything. So they can also pass through the food and kill the bacteria. That's possible. So you can keep the cooked food like fresh, okay, by irradiating it. We could have fresh food. That's possible for astronauts or those who are in the staying in space station. For them, it's difficult to get the fresh food, though they love it. The problem with that is it won't last longer, right? You have to consume it immediately. So fresh food is an option. Definitely, your astronauts on Mars can consume their fresh food as soon as it's harvested. Or we can have natural form, the foods such as like chocolates or nuts, dry fruits. You cannot do anything about that. They last longer naturally. So that can be vacuum packed. or intermediate moisture food, like such as the food in which you cannot just add water. Adding water doesn't give you the taste. You need to, it needs to have its own juicy content in it. So it can be like apricots, pineapple, pear. So some food which you need needs moisture in it are intermediate. So some meat also needed. Okay. Or we could have frozen food or refrigerated food. Now, the frozen food are just freeze-dried ones. That's okay. That's possible. Refrigerated food, such as like ice creams, big no. The reason is it consumes a lot of power to cool it. But you can think about it because Mars is a bit far away from Sun, so it is cooler there. So maybe that's possible that you could have some frozen food also. Okay, so these are the packed foods. If you have any questions, definitely do post your questions in the chat, or you can raise your hand, and I will continue there. So the advantages of packed food are they're immediately available. So definitely you need to have them. They are like your instant food that you have at home, all right? Or the disadvantage would be it increases the weight during launch, and it's not, like it doesn't give you the fresh feeling. So astronauts may not be happy all the time eating this food, right? So moving further, coming to the raw food like plant or meat, something that you need not worry about it being consumed, it getting over, right? You need not wait for the next batch to come and land for you to supply food for you. Something you're independent. You can, yeah. So that's what is plant or meat. So that's the raw food. So definitely you want to have raw food. What are the means? What are the methods that we can do it? But we can do it, but what do we need, especially coming to the plant? We all know, we know very well that we need sunlight, we need nutrients, we need air, oxygen, carbon dioxide, or air with, that can help the process to continue in the plants. We need water, that too in liquid form. Now, these are the requirements that we need to grow a plant. That's very simple. We all know that. All of us have grown plants, right? But what is the challenge on Mars? There's less air, meaning it's not dense enough. The air is too sparse. So it's less, no liquid water on Mars. We know that. We are hoping, yeah, there are like frozen parts somewhere, but not in a liquid state. How do you get it into a liquid state? The gravity is low, which might be a challenge while growing plants. And it's too cold, which is, we all know very well that when it's too cold, the plants, they find it difficult to thrive. So what do we do then? All right. So there are methods. Scientists have found few methods through which you can grow plants on Mars or on Moon or in space. So one method that they have obviously tried is already seed film technique. And I'm going to talk about hydroponics and aeroponics. Seed film technique are secured. So what do we do over here is we take a small plant pillow, okay, and there is the pillow is with the seed in it. So you give the nutrients into it, okay, and you put it inside this black colored plant case, so in which you have the soil for it to grow. And this is a batch which contains Tokyo Becana or cabbage and lettuce seeds, which they were successful in growing. So you can see that. So it's grown in space station. That was a success. So that's a good thing. Again, I'll show you a video where you can see what all the things that you would need to grow these plants. So definitely you already saw that this needs plant pillows. There is a seed film that is kept over here. There are these attachments that you see, those are like tiny attachments for the water supply that you needed. Is that enough? Is that sufficient? So you can watch the video. You'll get to know what other things are involved in growing it. I will play it very quickly, and then we will go further. Okay. Now give me a minute. There you go. So I'll play it from the beginning again. Okay. So yeah, basically you need something like a grow light, a protection so that it doesn't harm the other parts of your system. So yeah. Okay. So that's what you would need to grow with the seed film technique. Now, there are some challenges with the seed film technique too. That is the marsh soil. So I cannot take soil all the way from earth. That's going to be expensive, heavy, so expensive. So therefore, you will have to use the soil on the marsh, which contains calcium perchlorate, which is toxic to plants. Now, how are you going to? You need to think about what methods you could use. There are methods to get rid of perchlorate from the marsh soil. So definitely think about that if you're going to use this method. Okay, so moving further, that is about seed film technique. Then going to hydroponics. Hydroponics is a technique which most of the scientists are definitely looking forward to, incorporating it in space. The best thing, now already I was just now talking about soil. I said that soil contains perchlorates, Martian soil. The hydroponics method does not require any soil. There's no need of even a grain of soil there. What you would need over here, the word itself says it. Hydroponics, meaning hydro is water. So you need water to grow plants. Now you might think that, okay, it's going to consume a lot of water. But the reality is the water is recirculating. So you keep on reusing the same water. Now, this technique is not very new. It's already been utilized. We are using it on Earth to grow crops. So it has a good chance. There's a good research that can be done. So if you're going to use it even in space, it's possible. It gives higher yield. So I was talking to one of the hydroponic, farmer, and he said that to grow a lettuce, he could do it in just 32 days. He could have a complete harvest of lettuce, which typically takes, 2 or 3 months. It can be grown quickly. So higher yield, no pesticides, no problem with that. You can save water. That's the beauty of hydroponic technique. I'll talk about the challenges after I talk about aeroponics method. But again, I'm going to show you a video where you can see the system involved in the hydroponic method. Okay.
Hydroponics is a method of
There you go, there.
growing plants, usually crops, without soil. In this method, the crops or plants are grown on water rich in essential nutrients. According to studies, plants grown hydroponically grow faster and healthier than plants in the soil since they are being provided with required nutrients directly to their roots through water. Nutrients are dissolved in this water that surrounds the roots, so plants have easier access to the nutrition they need. Many different civilizations have utilized hydroponic growing techniques throughout history. The hanging gardens of Babylon, the floating gardens of the Aztecs of Mexico are examples of hydroponic culture. As the many benefits are realized, now scientists and horticulturalists are experimenting with different methods of hydroponics. It was even integrated into the space program by NASA as they are considering the practicalities of growing food in long-term space missions. Hydroponics allows plants to grow up to 50% faster than they would in soil, and fresh organic produce can be harvested throughout the year. It also helps to produce higher yields than traditional soil-based agriculture and allows crops to grow in areas of the world that cannot support crops in the soil. Hydroponics is good for both environment and the grown product since it eliminates the need for massive pesticide use compared to traditional soil-based agriculture. Hydroponic systems require only around 10% of the water that soil-based agriculture requires. The water used in a hydroponic system can be reused, thereby reducing the need for more freshwater supply. It is also a great option when there is a lack of land or yard space for gardening, as it doesn't require a lot of space and can even be done indoors.
Okay, so any questions about hydroponics? Okay. So similarly, aeroponics method is also just like hydroponics, but it's much, like it consumes even less water because you don't supply water continuously. You're just going to spray the water with nutrients to the roots. So, every hourly once. So all that you need to do is a limited supply of nutrients, not too much, not too less. And then it is just the remaining water just goes back to the tank. So that's aeroponics. It's a similar method like hydroponics, but much less water. Now coming to the challenges of these two methods, you need liquid water again. So think about how you're going to do that on Mars. You need to have a constant power supply. So that's very critical. So if there is no continuous, the water is not recirculating or it is not spraying, the plants will die immediately within like hours, within like, even in aeroponics, it's even less. In like 30 minutes, it can, all of your plants can just, wilt. So that's it's a huge loss. And you need to do regular monitoring. You need to supply the nutrients. If it's too much, then it will burn the roots. If it's too less, there is no good produce. So a good monitoring is definitely needed in this method. Okay. Now coming to meat. All right. We don't have only vegetarians or vegans going to space. We definitely have all kinds of people over there. So you cannot put animals in the spacesuit and send them. That's very difficult, Putting humans in a spacesuit itself, it's a big task, and putting animals is impossible. So therefore, there are methods through which you can grow meat without even slaughtering the animals. So you can definitely do a lot of research on this method. This is like tissue culturing, where you take a small sample of the body cells from the animals. You just take them out without killing the animal, without slaughtering it. And then you take it into your lab and you grow the meat, okay, providing the condition as needed for the animals. And then your meat is grown and you can consume it. Now, this technique is still developing, but definitely something for the next 10 years, it's going to be there. So I think I'll show you a quick video about the same. Let's see, I think this should be the one.
What we're going to try.
Okay, so let me put that on full screen. There you go.
Today are the first thin slices of steaks we have produced in a lab setting.
I think this is going to be the greatest revolution in the history of modern agriculture.
This lab-grown meat is not just a plant-based alternative like the Impossible Burger.
There's a technology that exists that allows us to, for all intents and purposes, have our bacon and eat it too, without any pigs being harmed.
Cultured meat, lab-grown meat, clean meat, whatever you want to call it, is identical to conventional meat at the cellular level, just grown in a lab, no slaughter involved. Its arrival could have massive implications for meat eaters, the US's $200 billion meat industry, and the environment. And it's happening at a pivotal time.
We can't handle more agriculture, and this growing demand is asking precisely that, and we're going to reach a breaking point.
We're in San Francisco on our way to Just. The startup invited us to try its lab-grown chicken nuggets for the first time.
Just started out by making vegan alternatives to animal products, like mayo and scrambled eggs. But now they're entering a new market. They're producing actual meat grown from animal cells in a lab.
All right, Chef Chris, we're gonna cook up some cells.
I like to call it chicken.
Well, we'll see if it tastes like chicken.
This is our chicken bite. Got some breading on it right now.
Bam.
All right.
On the inside, kind of airy on the inside.
Lab-grown meats start with a small cluster of cells that, like an embryo in a womb, needs proteins and nutrients in order to grow. The process generally begins with taking a tissue sample from a living animal. From that tissue sample, stem cells are isolated. From there, a nutrient-dense serum encourages the stem cells to multiply. Once a mass of cells is formed, it's fed with proteins that prompt the cells to differentiate into muscle and fat cells. After some time in a cultivator, a mass of cells resembling raw minced meat can be harvested and prepared.
All right, Chef Chris.
The moment of truth.
So I'll skip directly to the process where how they make it so that it's useful for you instead of all these talk. Okay, let's go to this.
May have found the holy grail of cultured meat production, a steak.
The world's already seen hamburger meats, but this is different.
Yeah, that's different. Those are pieces of steak. We believe that for cell-cultured meat to be a real option in the market, it has to reproduce the texture and the experience of the conventional meat.
Olive Farm's steak starts its life in this nitrogen tank. That's where the frozen animal cells are kept.
You gonna take us to the slaughterhouse now?
We don't have slaughterhouses, but we have cows. This cow is named Gertrude.
This is a cow named Gertrude, okay.
Yeah, and that's the second cow named Alberta. So this is Gertrude. What you can see in there are cells, which are actually real cow cells, which we have isolated from a real animal.
Is the cow still alive?
And we don't hurt the cow.
The conditions inside these refrigerator cows are meant to replicate the bodies of living cows, where cells naturally multiply.
So this is actually probably one of the, or maybe the first piece of beef tissue.
After roughly 3 to 5 weeks in Gertrude, these small beef pieces will grow into a thin slice of steak, roughly the size of a credit card. Most cattle are slaughtered after 2.5 years.
What we're going to try today are the first thin slices of steaks. Each meat cut you'll test today costs approximately $50 a piece. The taste and flavor are still, I believe, 60–70% on the way toward our goal.
You've gotten the texture pretty close?
Yes, not bad at all, and you can judge by yourself.
The company didn't want to show up.
Okay, so I'll stop it at that point. So yeah, so we can grow meat in space. We can have, raw plants. That's possible. The advantage of this method is unlimited supply of food. You're not dependent on anyone, but it is time consuming. It's going to take few months or few weeks before you get your final product. You can't make your astronauts starve till then. So what you have to do is you definitely need to have a combination of both. For the initial days, you can have some processed food. And for a long term, definitely raw food is required. And a good research on a space food is needed. Okay, so I would end at this point. I would say all the best for all your efforts. So you'll be forming your team. I'm sure think about what you're going to include, what type of food you're going to have in your space design, in your Mars design. Think about including the varieties. Any questions?
Yes, we have several questions have come through. First, I'd like to ask everyone if they could raise their Zoom hand. Would you try the grown meat? Would anyone here try that meat? I would be hesitant, not because I wouldn't trust it. I just think it would taste weird. Anybody here? Nobody would taste the meat, the grown meat in the lab? All right, okay. All right, so several questions. Can we use Martian water to irrigate plants? Is it safe?
Oh, that's possible, but definitely think about filtering it. So you cannot directly use them. So filtering is a must.
Okay. Will the astronauts need vitamin and mineral supplements? Will they get enough like nutrition for their food from the food they take, or will they need supplements?
So there are, I mean, like if you have a proper diet, if you plan it and you can supply everything with the help of the food that you grow there, it is possible. But for the initial days when it's difficult for you to provide all the different varieties, it might be difficult. So that time, yeah, supplement is a good option. Why not?
Okay. Do we need bacteria in the dirt on Mars to grow the plants? Can we just plant in the dirt or regolith as it is, or do we need to add anything?
So for example, if you want to get rid of perchlorate, you can definitely add bacteria. There's one method where you can remove the perchlorate and the bacteria are going to give you oxygen. So it's an advantage. So yeah, why not? They are like natural methods. You can do it. But how are you going to take them there? That's the
And the more natural, the better, I presume.
Yes, the natural. Always try to use the resources. That's the best.
Okay, thank you. How many calories does a person need to eat a day in space?
Oh, that depends on their weight, on their mass, and definitely on the task that they're going to do. But you can take an average. That's some number that you would definitely get if you Google it or Chat GPT. You can get that number. So don't worry much about that.
Okay, so it's just, I think what they might have been asking is because they're going to be under so much stress, will they need additional calories or will it just be the same?
Oh, okay. Yeah, it depends on the task that they are doing. So definitely you can give an average of the calories that they need to consume. At the same time, they need to burn some calories because they need to keep themselves fit over there. It's not like Earth. So yeah, a good calculation is needed.
Okay, good. What types of plants have been grown in Martian dirt or regolith, like on Earth in labs? Do you know? What are the best ones?
I know that you do get these, like pseudo Martian soil on Earth. It's possible. And I have not, I know like personally, some of my colleagues trying to grow something with that. Yeah, you can search about it. I cannot give you a perfect answer saying that this is the only thing that you can grow. No, there's a lot of research there. There is a scope.
Okay. So there's probably a variety of different.
Variety, yes.
Okay. What about do you know about the psychological effects of the varieties of food? Like in a previous contest, one of the groups said they were only taking algae to eat.
That's right. Yeah. That's what I said. Have a variety, please. I mean, like, yeah, you can say algae, they are good for health, but you cannot eat them for more than a day or two. And then your astronauts will be like going crazy and they'll say no.
Yeah, 2.5 years is a long time to eat algae 3 times a day.
No, impossible. You'll find them.
So you would recommend variety, as you said earlier. Okay. Is it safe to grow food on Mars and eat it?
Yes, that's definitely safe to grow food on Mars, but make sure the conditions that you provide, right? Like you cannot just use as I told you, you cannot use the soil directly and grow them. You cannot use the water directly and grow them. So make sure you provide the right condition. For the initial stages, it's always best to replicate what we have on Earth and do it in that way. Test your samples that you get out of it. And yeah.
Good. How does NASA prepare rehydrated food? Do they source it from a specific farm and then prepare it? Or do they get food from groceries and rehydrate it that way? Which way is more efficient?
Okay. So as I know, they do have these, the third party supplies, and there are a lot of research also going on in NASA. They do both the things. But when it comes to large supplies, they always go for someone from outside. So there's a tie-up that they have with another industry and they supply it for them. So there is a dedicated team for that. It is not just something that you get from the grocery. It's not like that because there's a lot of quality tests that goes into it.
Okay, that makes sense. Thank you. Any other questions from the students today? is there any current technology to mass produce the bioengineered meat?
I have seen that the technologies are coming up right now. So you can definitely do some research on that. I will leave it over there. I'll say you can do the research there.
Okay.
Would
Would
anything-
anything special or weird happen to the food once under the conditions of space?
Definitely. So when you say space, if you just leave it out just like that without, I mean, like humans as we know it.
Jay, the question's from Jay. Jay, do you mean in the spaceship and on Mars in the habitat, or do you mean like out in space?
Out in space.
So maybe he'll let us know. I'm like on Mars. On Mars. I believe what he's just in the spacecraft on the way and in the hab on Mars.
Okay, in the hab on Mars. So definitely your hab is going to be a replica of Earth, or similar to Earth, or at least similar to an aircraft, the condition within an aircraft. At least you will have that. So say if it's in that condition, the pressure is maintained, the temperature is maintained, you have a good humidity. So it will survive the same way like it does on Earth. Only the problem would be the gravity. So maybe your thing, I mean, the gravity is still also not that low as compared to maybe if you drop something, they keep a little bouncy, I would say. So that's something I would say. The conditions wouldn't change much, Jay.
Okay, and they'd probably be vacuum sealed, I would imagine, initially.
That's right. So definitely, what I'm thinking is right now, like according to Jay's question, it's on a bowl. So if you think like that, still. Okay. So if you take it completely out of your hab, then we need to think about it. So it's going to react with all the dirt and there is a lot of things going on out there. Carbon dioxide, and it's oxidizing immediately, or the pressure is different. Then your food will go. It will have some difference there.
Okay, and Scaffaroo, Edward, is this kind of meat more expensive than the normal one?
Yes, that's true, Scaffaroo. That the reason is because the technology is still developing, and it needs a lot of input from your side than the output that you're getting, right? So it is expensive at the moment, but in 10 years it won't be the same. Would it be worth bringing fertilizers to grow the plants faster, James? Yes, it will be. So when I'm saying, when you think about especially hydroponics method, you don't need too much of fertilizers. Instead of that, you provide nutrients. So nutrients is what that helps to grow the plants. The very common ones, potassium, PKS. Yeah, you need to provide those. So if you do that, they are going to be faster. And the sunlight. Yeah.
Yeah, phosphorus, potassium, sulfur, is that PK?
Yeah, thank you. Yeah. That's right, exactly.
I teach science every day.
Perfect. Yes, please.
Any other questions from the students? Is there any noticeable difference on an astronaut's body with different types of food?
I think you can be your better judge. If you're supplied with the same food every day, I would say, there is an effect of food on the growth. That's definitely there, especially in a growing period. Now, astronaut is a person who's an adult, well grown. Definitely, it will differ somewhat in the activity they would do, the energy that they would get. So that will differ. But more than that, it's the moral, or how they feel about it. It's all emotional again, so it gets into that part. So they'll be different. Yes,
I would guess that if we're preparing for a human mission to Mars, you want your astronauts to be in really good physical condition, like they would have to be. They would be tested and put through rigorous training, but just like on Earth, the different types of food are going to affect your body differently depending on your lifestyle. So I would think that definitely would make a difference depending on what they're doing and what condition they're in when they go, which hopefully they're in really good condition, right?
Yeah, that's right. Especially you want them to do a lot of tasks.
A lot. Keep them mentally and physically busy. And Jay also says, what about bone density?
Bone density definitely decreases because of low gravity, as we know very well. So you need to supplement, you need to make sure they are in exercise. Exercise is the one thing that will help them with respect to bone density, Jay.
Right. Bone and muscle density kind of go together. So if they're doing a lot of tasks, as you said, their muscle density would, you know, stay higher than if they're not doing the tasks, right? You want them to be physically busy all the time. So like, would food decrease that effect? Can you explain what you mean, Jay? Or you can just unmute yourself and ask if it's easier.
I'm asking, like, if you eat different types of food, would certain types, like, I guess, make it so you don't feel the effects of bone?
Okay,
I guess
would food help in reducing the bone, osteoporosis?
Like calcium.
That's true and not true, because it takes a long time for food to act on a body. For example, they do say, like, there are certain, in vegetarian food, for example, if you eat a lot of these lotus seeds or something like that, yeah. So those things do provide a lot of density to the bone. They help in strengthening the bone, but it takes a long time for that to act on your body. Right. So food helps, but you cannot just rely on it.
Especially under those conditions, right? It would be very stressful.
Exactly. That's true.
Good question, Jay. Anybody else? Well, while we're waiting for anybody to ask any last questions, students, I have shared with you a spreadsheet. If you were here earlier, you saw the spreadsheet to ask for your time zone. You do not have to share your email if you don't feel comfortable sharing it with everyone. Please send me at least your first name and your time zone on the spreadsheet so I can group you in proper groups based on your time zone. So you can work together during the day in your time zone. I don't want to put somebody in California and somebody in Southeast Asia on one team, because one would be awake and one would be asleep. Any other questions? Thank you, Ashwini, very much. And I'll be sending out emails as usual. And I appreciate it. And your talk will be linked in the syllabus as soon as it gets processed by James.
Thank you very much, Nicole. It's always fun to be over here and to work with these amazing students. You know, they come up with great ideas. So I wish you all the best. Don't become lazy. Don't become stressed. Enjoy this process. Do, go around, do a lot of research, talk to people. You will gain a lot through this.
Yes, you will all have mentors who will be able to help you. You can always email myself any questions. I'm sure Ashwini, if they have any questions about the food, I'm sure they'll be you welcome their questions. So everyone, we will see you tomorrow at 10 a.m. Pacific time for our next talk. Thank you very much.
Bye.
Bye. Bye, everyone. Thank you.